We are solving triangles that have potential here to be the ambiguous case. We're going to round angles to the nearest degree and side lengths to 1 decimal place. So first of all, let's check and see, is this a case where we have one solution, two solutions, or no solution? The first thing I'm doing is comparing side A to side B, and since side A is smaller than side B, I do have potential for either two solutions or one solution, possibly even no solution. So let's check the answer or the value of B sine A, which in this case would be 14.8 multiplied by the sine of 35 degrees. This gives me an answer of about 8.5, which is smaller than my side A, which gives us the fact that we have two solutions for this particular triangle. So there's two solutions here. What we do is we solve it with the sine law just as we usually would. So I'm going to set this up. I've got my angle A of 35 degrees. My side A is potentially, I'm just going to shorten that. Okay, my side A potentially would be 12.2 centimeters and looking like this. Here's my 35 degrees, and my side B is 14.8, so slightly longer than my side A. So my side A, my side B, and my angle A, that makes this angle B, and angle C is across from that unknown side on the bottom. Okay, so we set up our sine law. I'm going to solve for angle B, so I'm going to put the sine of angle B on the top, divided by side B, which is 14.8, and that's going to equal the sine of angle A, which is 35 degrees, divided by side A, which is 12.2. Now, to get sine B by itself, I'm going to multiply both sides by 14.8 and 14.8. Now, that undoes it on the left side, leaving us with just sine B. And that's going to be approximately equal to there we go, 0.6958. 0.6958. Now I leave all those digits in my calculator. In fact, sometimes I leave out that step and go directly to inverse function sine on that and get approximately 44 degrees. So that is the option where we have that acute angle B of 44 degrees. That means angle C then would be 180 degrees. Take away the 35 degrees and take away the 44 degrees. And that gives us 101 degrees there. Now that we have angle C, we can use the sine law again and solve for side C. So side C over the sine of 101 degrees would equal the side A, 12.2, over the sine of angle A, which is 35 degrees. And then that, when I multiply both sides by the sine of 101, I end up with about 20.9 to 1 decimal place. So that's one solution. So we have the possibility that we have B equaling 44 degrees, C equals 101 degrees, and side C is about 20.9 centimeters. That's our one solution. Our second solution comes from here. So at this step, this is where we veer off a little bit. If we had a second solution, we'd be looking at that side A coming down and meeting side AB. We're going to meet that at an obtuse angle instead. So this is still my 12.2, that green line, but my angle C now, or sorry, my angle B, that's side C that I have written on there, angle B could equal 180 degrees minus the 44 degrees. So it makes it an obtuse angle. It's 136 degrees. That then means that angle C is going to be 180 degrees minus the 136 degrees minus the 35 degrees. That angle C is going to be really tiny. That gives us 9 degrees for angle C. So we have angle B, angle C, and now we can solve for side C again. Side C would be now the sine of divided by the sine of 9 degrees would equal the 12.2 divided by the sine of 35 degrees. So that's side A divided by angle A. And that gives us that side C would be approximately, there we go, 3.3 to 1 decimal place, approximately 3.3 centimeters. So that's the second solution. Okay, so our two triangles either have angle B being 44 degrees, angle C 101 degrees, and side C being 20.9 centimeters, or angle B is 136 degrees, C is 9 degrees, and side C is 3.3 centimeters. Try solving, checking out example B, see if it's one solution, two solutions, or no solution, and then go ahead and solve that. All right, checking this one out. Triangle DEF, if D is 5.3 kilometers, E is 4.7 kilometers, and angle D is 75 degrees. So angle D is fairly big. Angle D is 75 degrees. Side D is 5.3, which is bigger, 5.3, which is bigger than side E, which is my other side, 4.7. So this, because that side D is bigger than side E, there's only going to be one solution. Okay, so since D is bigger than E, only one solution. And you can use the sine law to solve for angle E. And then the angles add up to 180 degrees to get side F, or sorry, angle F, and then you can solve for side F using sine law. Okay, I have my solution here. Check your work and make sure that your answers agree with mine. There's always that chance that I've made a mistake. All right. Check out letter C here, triangle GHI, if side G is 9.6 meters, H is 12.3 meters, and angle G is 43 degrees. So decide if it has one, two, or no solution. Okay, if I have an angle of 43 degrees, so that will be my angle G. My side G is 9.6, which is shorter than my other side of 12.3. So let's check and make sure that it is long enough. We already have it shorter, so let's take a look at, this will be G, H, and I. So let's check H times sine of G to see, is that side 9.6 going to be long enough to create a triangle? So 12.3 times the sine of 43 degrees. That gives me 8.4 approximately. So it's definitely long enough to make a triangle, so we're going to have two triangles here. So since G is between that H sine G is smaller than side G, which is smaller than side H, there are two solutions. And then from here, we're going to use the sine law like we did on the previous part A question. Okay, and in using the sine law, I found that angle H had a value of 61 degrees, and angle I had a value of 76 degrees, and side I had a value of 13.7 meters. From there, I'm going to find my second triangle value as I'm changing my pen and trying to find the right spots. So that would be the triangle that has the side coming down this way instead. So it looks like that. And then to get that, my angle H would be 180 degrees minus my old angle H, the acute angle of 61 degrees. So 180 minus 61 should be 119 degrees. And then we can solve for angle I, which would be 180 degrees minus 119 degrees minus the 43 degrees. Angle I is going to be very small again. That gives me 18 degrees. And then we can solve for side I using the sine of 18 degrees, along with the side that's G, 9.6 over the sine of angle G, which is 43 degrees. And that gives me a value for that side length. And bear with me while I put that in my calculator. And I get about 4.3 meters. So that is my second solution. And I'll just tidy that up by adding in the symbols. So there we are. And that's how you solve an ambiguous case of the sine law triangle.